In this presentation, which is part of our core air conditioning course, we're going to be talking about pressure gauges. Now, pressure gauges are instruments that measure and display the pressure of fluid in a container, and they're also gauges that display air pressure as well. Pressure gauges are an important tool that a technician can use and provides valuable information for what is happening inside a refrigeration or air conditioning system. There are several different types of pressure gauges that function using different principles of operation. They also are available in a wide variety of ranges, as the pressures measured can vary from a vacuum, which is a negative pressure, up to 800 psi or higher. One widely used operating element that pressure gauges use is the board-on tube. The board-on tube is a thin-walled tube of elastic metal that is bent into a circular shape that straightens as the pressure inside of it increases. So one end of the board-on tube is sealed closed, okay? That is all the way at the end. The other end is connected to a fitting that connects into a valve on the refrigeration system. So again, this is the original shape of the tube. Now, as the sealed side is connected to the linkage with a special engineered gear with an indicator dial. So what we have here is we have our gear that turns, okay, and the dial is connected to that gear. As the pressure inside the tube increases, it becomes bent out of shape. And that bending action will actually drive that gear either clockwise or counterclockwise. Operating pressures vary with different types of refrigeration systems. Some pressure gauges use a built-in, it's called a retarder, with the board-on tube to measure readings at higher pressures. After the pressure has been crossed a certain pressure threshold, a retarder engages an extra spring that correlates with the gauge's high graduated markings. In other words, there's a point in here where it's actually going to shift values to a much higher pressure. Okay, and this picture here shows it. Okay, we have the green is a vacuum, so that's going to be a negative pressure. Then all of a sudden, when you get up into over like 125, we go into what's called the retarder mode. Okay, and that will give the measurements up to 340. In other words, it's a little bit of a different spring and a little bit of a different accuracy. There are three main types of pressure gauges used in HVAC service work. You have vacuum gauges, you have compound gauges, and you have high pressure gauges. Each gauge has a different scale that depends on the refrigerant being measured. Vacuum gauges go 30 inches mercury vacuum through 0 inches mercury vacuum. Compound gauge goes 30 inches mercury through 240 psi. In other words, it does both a negative and a positive pressure. High pressure gauge goes 0 through 800 psi. So again, the high pressure side only works over 0. A vacuum gauge measures lower than atmospheric pressure. Atmospheric pressure is at 14.7 psi, which is 29.92 inches mercury, or 760 torr. Digital vacuum gauges can include the following scales: microns, psi, inches mercury, pascals, millibars, torr, or millitorr. Okay, and you can actually press the scale to select the different units. Most often now with vacuum, we are using microns. A micron is equal to 0.001 millimeter of mercury. Hg is mercury. In the micron scale, a perfect vacuum is 0 microns, and increasing the pressure represented by increasing the measurement. A measurement of 25/400 microns is 1 inch of mercury, or 28.92 inches of mercury vacuum. And that's a higher pressure than 0 microns. The pressure drop lowers the boiling point of a refrigerant. To force moisture inside a system to evaporate at room temperature, a vacuum pump is used to create a vacuum of about 250 microns in the system. To measure such a deep vacuum, a micron gauge is used. A regular compound gauge cannot accurately measure deep vacuums, so you have to have a gauge that goes into microns. So if a vacuum drawn on the system and the vacuum gauge's reading levels off at 5,000 microns, there's still ice or water in the system. Remember, the lower number is a deeper vacuum. The location of the ice may be indicated by cold spot, frost, or sweat on the outside of the system. Close the valves connecting the vacuum pump to the system, stop the pump, allow the ice to melt, or use a heat gun or thermal blanket or a heat lamp to melt it. A compound gauge measures pressure above and below atmospheric and also vacuum. It's known as a low side gauge. But you cannot use a compound gauge just for drawing vacuum. It does not do microns. Most compound gauges are typically calibrated from 30 inches of mercury vacuum to 0 inches of mercury vacuum for below atmospheric pressure, and 0 psi to around 350 psi for above atmospheric pressure. Some compound gauges include evaporating temperature scales that make it easy for the technician to determine the evaporating temperatures of different refrigerants at the measured pressure. A high pressure gauge is a pressure gauge that can read high pressure values on a single continuous scale. This scale can go as high as 800 psi. High pressure gauges are also known as high side gauges. The high pressure gauge is usually connected into the high pressure side of a system into the discharge service valve, liquid line service valve, or liquid receiver service valve. HVAC instrument manufacturers have combined pressure transducers and wireless technology to produce wireless gauges. These devices have capability to send data to mobile devices for remote pressure sensing and easier record keeping. Installing one transducer on the high side and another on the low side allows the technician to read system pressure without using a gauge manifold. Some products also include temperature transducers to use when determining superheat and subcooling. An example of this is the Testo smart probes. So again, this is just, someone's putting pressure transducers on here. You might have pressure and temperature together, and then you can display these on your digital gauges, okay? Compared with using the old style of the having to calculate superheat, subcooling, and everything else with the long hoses. Now, one of the benefits of using the transducers with the very short hose alignment here we have is that you do not lose a lot of refrigerant, yet you have a lower chance of putting contaminants into the system you're testing. There are some pressure gauges designed specifically for use on certain systems or with certain refrigerants. While many gauges can be used for measuring most types of refrigerants, others are intended for only one refrigerant. Two special cases here are ammonia system and hydrocarbon systems. Ammonia can corrode copper if moisture is present, and hydrocarbons are flammable. Hydrocarbons would be like a propane system. Okay, so again, we have ammonia gauges and we have the isobutane gauges, which is the hydrocarbons. Please note, but ammonia is an inhalation danger. You cannot breathe it in. Propane obviously is a flammable situation. Do not light a match near this and don't have a spark. A variety of things can damage your gauges. A sudden release of high pressure, such as 300 psi into a gauge, can damage it. Rapid fluctuating pressures can rapidly ruin a gauge's accuracy. When checking gauge accuracy, remember that calibrating equipment is made to show a 0 psi reading at sea level. You can get liquid-filled gauges to prevent fluctuation. They have a glycol fill, and you see a little bubble in it. But you can get liquid gauges to prevent these fluctuations. A gauge calibrated on equipment adjusted for pressure at sea level will not be accurate high above sea level or below sea level. Gauges need to be recalibrated to read 0 psi for the elevation of the area they will be used. To make adjustments, disconnect the gauge so it's open to air. Set the needle to 0. This is usually done by turning a calibration screw on the gauge, and you take the cover off and there's a calibration screw right there you can get with a low screwdriver. To protect pressure gauges from falls and rough handling, equip them with protective boots. Okay? You can get boots to put around the gauges so that you don't drop them. Okay, take care of these gauges. They'll last forever if you take care of them.